Hello, my name is Ethan Ortiz. I'm with HereYouCo LLC. In this video, I'll be covering TOR Hidden Services with client authorization keys. This will be part one of a multi-part tutorial. In this video, I'm going to go over the pros and cons of regular TOR Hidden Services and TOR Hidden Services with Authentication Key. I'll briefly mention how to install TOR on a Raspberry Pi, which is actually quite simple. I'll go over editing the TOR RC configuration file where you put your port translations from TOR to your local area network resources that are not running TOR. I will go over editing the TOR RC configuration file on the TOR Browser so your TOR client can access your TOR Hidden Service successfully using the authentication key. The target audience for this tutorial are folks who just want to access their LAN resources when they're away from home, but don't want to expose their LAN resources either to the open internet or rely on cloud providers to host or relay their communications. I'll go over the environment and configuration without hands-on keyboard at the command line. In this slide, I'd like to first start with the commonly used TOR Hidden Services, some pros for TOR Hidden Services. 1. Increase your network services anonymity. Another pro, you can easily share the onion address, and all the client need do is download TOR Browser and paste in your address in the URL. There are a few cons against TOR Hidden Services. Your address is still listed in the TOR directory and discoverable. Your service can be used to determine time zone, maybe assuming you turn on your services on and off consistently, of course. If you randomly turn them on and off, it's a little harder. Anyone who has your address can attempt to connect to your resources. And anyone who has your address can attempt to exploit your resources. Because if your resources are open, they are conceivably open to exploitation. Let's now jump to the pros and cons of TOR Hidden Services with Authentication Key. So pros for Authentication Key: increase anonymity, of course. In order to access your TOR Hidden Service, the TOR client must also contain a second piece of information, the Authentication Key, in order to even rendezvous with the TOR Hidden Service. If a TOR user can't rendezvous with your system, then they have a much harder time port scanning, banner grabbing, and exploiting your TOR services. One pro that may not be apparent immediately is the benefit of running out-of-date software, since random users or those nefarious folks can't find your old unpatched service to hack into. Cons wise, you will have to make sure the keys are transferred via a super secure manner, since anyone with the authentication keys can find and connect to your resources. This means, of course, that you have to properly manage your keys. Another con is the limited number of supported keys. TOR with authentication key is not meant for many to one, which is why I would only use this authentication key for my own communications when remoting back to my home resources. Here are some devices some folks have exposed to the internet: Arduino devices, Raspberry Pis, those weekend geek projects using ESP8266 devices that have been connected to Wi-Fi, and of course laptops and servers of every stripe. With all these types of devices potentially connected to the open internet, this may expose devices to exposure to random port scanning, random exploit attempts, exposure to denial of service attacks, and identification of availability. This is a demo environment to show a variety of computers, large and small, from desktops to Raspberry Pis. This Octoprint 99 system that I have listed here, that's my 3D printer web camera. I use it to monitor my 3D print jobs. In the second part of this video tutorial, I'll show hands-on at the command line how to SSH, SCP, and PuTTY to this Octoprint 99 Raspberry Pi. But this is an example of an environment that would have the port translations. And here are those port translations. So when I set up TOR on the Raspberry Pi up here, there's the black box, for a TOR client to access all of these resources on the LAN, the TOR Hidden Service needs to offer some kind of port that translates to these local devices. Since some ports are the same, such as the use of port 22 on all these servers on the left, I created my own mapping style. I used the IP address of the LAN resource followed by the port number on that device. This will not work with all services, of course, but it's good enough for the typical small environment. I'll be covering mostly accessing the 3D printer camera and SSHing on the Octoprint 99. Yes. So let's go over the steps to enable TOR Hidden Services with Authentication Key. We'll begin on the server side on the Raspberry Pi. I'm assuming you have a Raspberry Pi with an operating system installed. I used Raspbian, and all I had to do is the following. You'll need to console in via SSH into your Raspberry Pi, or plug in directly to the console. To install TOR, you just need to type sudo apt install TOR. After installation of TOR, it automatically starts. So before we jump into making changes to the TOR RC configuration file, I suggest you shut down TOR by issuing the following command: sudo service TOR stop, and then validate that the command took effect by typing ps-ef and then grep for TOR RC. If you don't see it running, then you can move on to the next step. The installation installed some binaries and some configuration files, and these are some key locations to be aware of. For our configuration, we'll mostly be concerned with making changes to the etc TOR RC file. You'll be entering all your TOR to local LAN port translations into this etc TOR RC file. So make a note of that specific file. And of course, you'll need to sudo in order to edit that file. Use your preferred editor to edit etc TOR RC. These entries are an example of what my TOR RC would look like if I wanted to enable access to the local resources I showed earlier, but over TOR. Remember the IP port combination from slide 6. You'll obviously need to edit this file to match the resources that you want to make available in your environment. The hidden service port 9922 would be the port that a TOR client would use to access SSH on my machine with a IP address of 192.168.110.99. Remember, there is nothing special about my port 9922. I just use the IP address combination to remind me that if I use SSH to go to IP address 99, I'm just going to go to port 9922. Now, please note the hidden service dir of varlib TOR hidden service. That's a directory because this is where a file named hostname will be created that you'll need to access to obtain the authorization keys. When you first start TOR, that directory is not there. Once you make these changes on the TOR RC file and restart the service, then that directory gets created with the authorization keys. So let's start TOR up again. So sudo service TOR start, and then check that it's running. There are many ways to obtain the contents of the hostname file, but I like to type sudo -s and then type in my password, and then I'll navigate to the file system hostname file location at varlib TOR hidden service. I run a more on the hostname file and copy one of the keys. Here's an example of one of those keys. So our TOR server is now running with other authorization keys enabled. Now we need to configure our TOR client to access these services. So we'll go ahead and copy this long string right here. Now we move our focus from the TOR server to the TOR browser configuration. First, of course, download TOR browser from this URL. Make sure you're using HTTPS. Fortunately, TOR browser is available for all these operating systems, so that should hit pretty much everybody. Once you download TOR browser, you'll have the ability to jump on the Onion network and reach any TOR hidden service node, but not yours because you haven't configured the authorization key. So next, you need to navigate to your TOR's TOR RC file location. So step 1 shows you where you should be able to find the TOR RC file. Open the TOR RC file for your TOR browser and add a line at the very end that has the word hidservauth, exactly as I spelled it there, in front of your Onion key address that you copied from the hostname file. This tells TOR Browser that anytime you visit this onion site, starting the onion site starting with XW5 in my case, it will use this key to authenticate in order to rendezvous with the service inside of the onion. Ultimately, once both the server and the client side are configured properly, you will be able to launch the TOR browser and simply type the onion address without the key, just the onion address with the port of your choosing, and you'll be able to access that resource on your LAN. So in my Octoprint 99 web server example, I would type 9980, and this would get me to the Octoprint web interface. But if I use a webcam slash and question mark action equals streams, that will feed me the camera feed from that device. Let's take a look at doing just that. So if you were going to access that camera on your local area network, then you would type your local area IP, your port. In local area would be port 80. Sorry for that typo, and you'd be good to go. But on your TOR browser, you would type in the onion address 9980 and cam, and you're off to the races. You can access that web camera. Now remember, with my IP port combination, I would simply need to change the first number to the IP number. So my 192.168.110.22 SSH would be a 2222. And obviously it would not be on a web browser. I would use SSH or PuTTY. In part 2 of this tutorial, I'll go over doing just that. I'll go over the hands-on portion of the tutorial where I'll show the entire process of installing TOR, configuring the hidden services with Authentication Key on a Raspberry Pi, and how to use SSH, SCP on Windows running Windows Bash. I'll also demonstrate the use of PuTTY for remote access over TOR and using FileZilla file copy over TOR on a Windows machine. If you like this video, please let me know by hitting the like button, or better yet, subscribe to be updated on my future cybersecurity videos.